Welcome to the Explainer. So, picture this. Your browser workflow works perfectly on Monday, but completely fails by Tuesday. What's the first thing you do? Well, most engineering teams immediately start checking the script. Did the selector change? Did the page update? Did the whole login flow break? Sometimes, yeah, that's it. But honestly, often the problem is way simpler. Your browser session just wasn't managed properly. If your workflow keeps asking for login, verification, or CAPTCHA again and again, the issue might not be the application at all. It might just be lost session state. Today, we're going to solve the incredibly frustrating problem of endless CAPTCHA roadblocks. You see, every new browser session starts completely from zero. Zero cookies, zero stored state, zero history, and zero trust signals. I want you to think of a browser session as a trust bank. A fresh brand new session is basically an amnesic bot with absolutely no trust in that bank. And for CAPTCHA-sensitive workflows, showing up as an amnesic bot guarantees high friction, repeated logins, really flaky QA tests, and an enormous amount of unnecessary manual work. So how do we fix this? Well, here is our technical blueprint to eliminate that friction. First, we'll cover the zero trust problem. Second, why persistence works. Third, we'll compare cookies versus full profiles. Fourth, session warming strategies. And finally, we'll run through some troubleshooting for common errors. All right, section 1, the zero trust problem. Let's dive right into this. When you fire up a completely fresh session, your CAPTCHA frequency is going to be incredibly high. Why? Because you have absolutely no trust history. You're an unknown, suspicious user. But as you add state, that frequency drops. Warm the session up with some browsing history, and it drops to low, thanks to those organic behavior signals. A truly persistent profile boasts a very low frequency because you fully establish trust. That's exactly why browser session persistence is not just a neat automation shortcut, it's a fundamental reliability strategy. Moving on to section 2, why persistence works. Building that long-term session value requires a solid game plan. You have to stop treating sessions as disposable. Step 1 is identifying your workflow. Which process actually depends on browser session state? Is it QA testing, onboarding checks, internal operations, or client-authorized automation? If the workflow depends on session continuity, it absolutely needs a strategy. Step 2 is defining that strategy, deciding exactly what should persist. And step 3 is assigning ownership. Someone on your team needs to own session health, lifecycle rules, and monitoring. Because if nobody owns the session, well, nobody owns the failure. Section 3, cookies versus full profiles. When you're defining your strategy, you've got to ask, what should actually persist? You generally have two main paths here. Basic cookie persistence might be totally fine for simple continuity, but full profile persistence, like saving a complete Chrome user data directory, preserves a much wider range of browser states. It really depends entirely on your specific workflow and how much trust you need to carry over from run to run. Preserving the entire directory keeps things like IndexedDB intact, which actually maintains internal state for things like reCAPTCHA. That's a huge deal. But to know if your persistence is actually working, you need step 4 of your strategy, documenting normal behavior. What does a healthy session look like? Should the workflow stay logged in? Should verification happen rarely? If you don't define what normal looks like, you won't know if a redirect or a CAPTCHA prompt indicates a real problem. 6. That number represents the 6-month lifespan of a Google NID cookie, establishing a great long-term trust baseline. Which brings us to step 5, setting lifecycle rules. Sessions shouldn't live forever by accident. You must define explicit lifecycle rules. You need to determine exactly when sessions are created, reused, refreshed, rotated, or completely deleted. And to brilliantly illustrate the contrast, 15, as in 15 minutes. That's how long a Cloudflare CF_clearance token might last, requiring really regular refreshes. A saved session only works well until it expires, becomes stale, or no longer matches the environment. That's why those lifecycle rules are absolutely critical. By the way, for the developers out there, persistence works identically in headless Chrome mode. Those user data directories carry the exact same trust signals. But remember step 8 of a good strategy, review your authorization. If a workflow involves bots or third-party systems, boundaries matter. These should only be used in owned, client-authorized, or contractually permitted environments. All right, section 4, session warming strategies. You have to actively build trust before putting a session to work. You start with that fresh session, introduce organic behavior to build up trust, and end up with a warmed session that triggers way fewer CAPTCHAs. And this ties into step 6, monitor your workflow outcomes. Don't just measure if the browser opened. Measure if the task actually completed correctly. You're building this trust to protect the workflows that depend on it. A super common question is how many profiles to maintain. 5 to 10 per target site is usually the sweet spot. You rotate them to avoid rate limiting any single profile. Also, step 7, always create a fallback path. If a session fails, what happens next? Does it retry, rotate, escalate? You have to decide this before an incident happens. Which leads us to section 5, troubleshooting common errors. Let's look at how this builds into real-world debugging. So if you run into a profile-locked error, the fix is incredibly actionable. You just need to kill the hanging Chrome processes and remove the singleton lock file. Boom, unlocked. But what if your CAPTCHA rates climb over time? That's a sneaky one. It usually means your IP is flagged, so make absolutely sure you're rotating proxies per profile. If your task still fails after doing this, your session strategy just isn't reliable enough yet. To sum up the operational benefits here, you can share sessions, match your time zones, and dramatically reduce your reliance on external solvers, which literally saves you API costs. Just be sure to avoid the common mistakes. Don't assume saving cookies once means it'll work forever. Never share sessions across completely unrelated workflows, and don't ignore session expiry. So, I want to leave you with this provocative question to make you rethink your entire automation architecture. How many disposable, zero-trust sessions are you wasting right now? Don't just ask, can we save the session? Ask who owns it, when it expires, and what happens when it fails. Stop throwing away your trust history, treat your browser state as a critical asset, and watch your reliability skyrocket. Thank you so much for joining me for this explainer, and hey, happy automating.